Hi, I'm Jesse. I'm a software engineer working at an IT company specializing in education industry based in Tokyo. So my Twitter account is Jesse Tetsuya. So I mostly work in both data science and engineering, and I've been involved with several data-driven projects, and I've been implementing ML APIs and ML Ops environment. So prior to the current job, I used to study the relationships between the online learning behaviors and online learning outcomes of higher education in the UK. And before that, I used to maintain and develop the learning management system used for vocational skills and prep schools. So based on these experiences, I'm going to try to talk about transformation from research-oriented code into machine learning APIs with Python. So the reason I'm going to talk about these topics is because recently Python engineers have more opportunities to work with data scientists and researchers than before. So understanding the processes to develop ML APIs can help make AI ML projects work more smoothly. So the target audience might be engineers who are working with data scientists or researchers, or engineers who are involved with AI ML projects, or researchers or data scientists involved in AI ML projects. But this topic seems to be very broad. So the development process can be different depending on each situation of your working place. So before getting down to the main topic, let me tell you the two premises in this talk. So in this talk, I used sample data and codes for educational technologies. So let me share what educational technologies are like, what data can be stored, and how they are used. So there is one major type of educational technologies, such as learning management system or online learning platform. For example, these are Moodle, Blackboard, Udemy, edX, Coursera, and others. So these systems have several functions to help learners to study online. For example, online quiz function can be able for students to take online quizzes. By using the functions, teachers can make online tests and distribute them to students. So video function can make it possible for students to take a lesson from home through a PC screen. So while they are using these functions, the learning log data is stored in database behind the learning management system. So generally, the characteristics of the learning log data has time series format. So the data include what students take online tests, what kind of online tests are distributed, when students online tests, and whether they answer the quizzes or not, and get correct answers or not. So by using learning log data scientists write research-oriented code through finding optimal ML models or algorithms. So engineers transform the research-oriented code into ML APIs and integrated them into the learning management system or the online learning platform. So this talk focuses on the process of transformation from research-oriented code into ML APIs, which is surrounded by a gray box on this slide. Okay, all right. So now let's get down to the main topic. So there are 4 steps to transform research-oriented code into ML APIs. So understand the research-oriented code, modularize it, refactor it, and write the code to check how it can behave correctly. So the first step is to understand the research-oriented code. So I'm going to answer these questions. What is the research-oriented code? What are ML APIs? And how should engineers handle research-oriented code? So I will use a Flask in sample code in this talk. So let's look at the definition of research-oriented code. Research-oriented code in AI/ML projects is code written mainly by data scientists or researchers for figuring out the most efficient and suitable machine learning model. So machine learning APIs are composed of 3 elements: preparation code, preprocessing code, ML code, or calculation code. So researchers focus more on writing preprocessing code and ML code, or calculation code through an iterative process, and then it is integrated into production code. On the other hand, engineers have responsibility to write whole part of the code in production level. So this is an example of pre-processing code written by researchers. This code seems to be long function and used for loop, and this code can allow researchers to visually trace the code from the top to the bottom and easily and quickly write that. So this is a sample ML code with logistic regression. This code can use DOTAPAN and use data frame, but it can make researchers easily handle input data and trace output data with data frame. So this code is an example of the code written by engineers. This code seems to be much shorter than previous code, and there is computation, and set computation, and there are two simple functions at the bottom. Actually, this code can build the model in a much faster and simpler way. So I identified three differences between a research-oriented code and the production code. So there are different scopes, different characteristics of coding styles, and different objective coding styles. So researchers focus more on writing pre-processing code and ML code. On the other hand, engineers have a responsibility to write whole part of the code in production level. So the research-oriented code seems to be easily handled and visually traceable. On the other hand, the production code need to be concerned about high correction speed, high readability, and they should be testable and modular. This is because researchers focus on finding the most efficient and suitable machine learning model, and on the other hand, engineers have responsibility to make the code work on server quickly and reliably. So now, what are Python engineers supposed to do for research-oriented code? So modularize the research-oriented code into preparation code, processing code, and ML code, and refactor them, and write the code to check how it can work quickly. So second step is to modularize the code. So there are three small steps. First of all, categorize the research-oriented code into preparation code, pre-processing code, and ML code, or calculation code. So second, break them out into functions and make them testable. And last, qualify input and output of the code and define URI. So this is a page of sample research-oriented code written on Jupyter Notebook. So this code is written for calculating probabilities to get students correct answers for certain questions of exams. This code is procedural and some of them are not classified, and it could be harder for us to understand the role of each code. I actually wrote it, but I struggled to understand the code. So this is because this research-oriented code seems to be tightly coupled. So in order to categorize this code, find the code to load input data or access database first, it can be categorized as preparation code. So next, find the code to make a replace, filter, or delete input data. It can be pre-processing code. Then find the code to execute calculation or train data. It can be categorized as ML code. So I could categorize research-oriented code into preparation code, pre-processing code, and ML code, like the table on the slide. At the same time, we could get modules for each from one page of research-oriented code. So preparation.py has functions to access the query, execute query, and load input data in rename columns. Preprocessing.py has functions to replace categorical data with discrete numbers and filter input data. Prediction.py has functions to calculate parameters, logistic regression, and item response theory. Item response theory is also called as two parameters logistic regression. This is just used for calculating probabilities to get students correct answer. This statistical method is used mainly in pedagogical domain. So yeah, now we can see the research-oriented code became loosely coupled. So there is a table of input data on the left side, which is used for two parameters regression. On the right side, there is a table of output data calculated by the model. So the input data is about whether students answer each question correctly or not. So there are item name, which is the name of questions, item ID, how difficult each question is, subject names, exam names, and correction, which is binary data. On the other hand, output data is about probabilities to answer questions quickly. The role of the API is to get probabilities so we can directly level probabilities as a endpoint name. So based on best practices, function name should be verb or verb plus noun. The role of this function is to calculate results or get probability so we can level calculate results or get props as a function name. So understanding what data is input and output, which means understanding what data the code calculates and makes, is considerably important step to make API. So now we could get and create a skeleton of the ML API modularized from a page of research-oriented code. So now we can move to refactoring phases. But we need to prepare for refactoring first. And there are two main parts of refactoring, which is I/O and pandas code. So let's look at these processes in more detail. So I did not include the refactoring of ML code. This is because ML code tends to be short, and also most of ML code is based on ML libraries. So there might not be spaces to rewrite or fix. So yeah, the preparation code and the pre-processing code tend to be more redundant and repetitive than ML code. So big ball of math means unstructured code. So unless we make the code more maintainable, the code to prepare and pre-process data will be the big ball of math. So during the proof of concept, which showed development cycles, for example, when rushing to write code and develop model, and at the same time feeling business pressures, we tend to create big ball of math with the code to preparation and pre-process. So we try to input several kinds of data and check output rather than we try to use several kinds of algorithms. So after we finish to quickly write a research-oriented code and look back to the code to prepare and pre-process, we can see several groups of redundant or repetitive code. So in this section, I will tell you the process to clean the redundant and repetitive code with sample code. So before starting to refactor, we might need to understand more about the code. In order to narrow down the requirements of each code, write the test code and take notes about the requirements of each code. So there are directories which I modularized in previous slides. The API directory has up.py, which is an endpoint to get probabilities and config prediction, and config prediction.py and preparation.py and preprocessing.py. So the test directory has 4 modules of test code for each. So when taking notes in this code, you can use sharp comment out or docstrings. So there are 4 kinds of docstrings, such as a restructure star, numpy star, Google star, and it is slightly different, but type hint. So you can choose one that you like, and I prefer to use Google star because other stars say parameters instead of arguments, and I feel more comfortable for using arguments instead of parameters. And on top of that, type hint can be one of the options which some of you already come up with. But yeah, actually any kinds of methods are okay to take note. Understanding the requirements of each code is most important here than how to write documents. So after we wrote test code and understood more than 70% or 80% of requirements of each code, we can start to refactor it. So I'm going to show you a case study with a refactoring the code to access BigQuery and the GCS by using Google Cloud client libraries with Python. Yeah, there are two kinds of code on this slide. The code A uses star and extract all of data from dataset and output two-dimensional arrays. The code B has a role to extract three specific kinds of data from a dataset, only when column 1 is not null. So the query filters values and drop null. I suggest that you pre-process the data with query as much as possible if you use BigQuery. This is because it is faster and lower cost than pre-processed data with Python. The cost and the processing speed of the BigQuery is increased based on the amount of data processed. So when you're writing preparation code to access GCS, I suggest that you make bytes objects and upload it from memory to GCS with Python. I tended to write the code to make CSV files on local, load it, and upload it from PC to GCS. This is because it allows me to quickly write the code. So as a result, a large amount of CSV files sometimes staying local and consume extra memory of PC. So I suggest that you make byte object. However, this code seems to be very long, so I should simplify more by developing or using wrapper library. There are two kinds of code with Google client libraries, which I showed in the previous slides. So it combines and simplifies two kinds of codes. In so doing, it reduces the total amount of the code. So GCP Accessor is a package I developed. So after this talk is finished, if you have interest in it, please feel free to contact with me. So now we can transform coding style with pandas into coding style with Python in pre-processing code. So all data in the API should be processed using the same data type. This improves readability and maintainability as opposed to prioritizing coding speed. So one day I wondered why I struggled so much with refactoring of the repetitive code of pre-processing in research-oriented code that I wrote previous week. The reason is that there are many kinds of coding styles with pandas, as you can see on this table. For example, free-to function has 6 kinds of coding styles, and I think that there are more than I wrote here. And in case of coding style with pandas, Python, it just uses basically list computation in each function. On top of that, the different styles of code with pandas tend to be repetitive when trying to pre-process data in different ways. So pandas is very powerful and useful for data wrangling, but the code might decrease readability depending on each situation. So the way of coding without pandas could be easier for engineers to read the code, and it could increase readability and maintainability. So last step is to write the code to check if the code can work correctly. So there are 2 things to do. Write decorators to check parameters and setting up production-like environments. So this is the image of decorators in APIs. So after client send the request, APIs check whether parameters are correct or not and check access token. If something wrong with the code happens, then the error handler will catch error. If there are nothing wrong with the code, request will reach to the endpoint. I don't have enough time to describe all of them, so I'm going to focus on talking about request parameter check. So I'm going to show an example of request parameter check with JSON schema. This request call command has student name and student grade as parameters. This JSON file is sample JSON schema. In this file, you can define what data should be checked and how the data should be checked. So this make name grade.json file is defining the data type of student name as string, and it must be included as the request parameters. And the data type of student grade is also defined as string, and it must be included as true. And the maximum length of characters is limited in 120, and the minimum length is 1 character. So in this example, request parameters are not allowed to be empty. So based on JSON schema, the JSON validate2.py validates request parameters. The first validation validates JSON function, checks whether the JSON schema exists or not. The second validate schema function checks whether the request parameters are correct or not based on JSON schema defined in previous slide. So in order to execute these functions, write function name as a syntax trigger under the endpoint. As I looked over JSON validation code in the web, most of the code like this on this side, so you can easily find a lot of similar sample resources on the web. Yeah, finally set up production-like environments with Flask. They are just tools, and this conference is about Python and data. So I don't talk about how to use them in tutorial. So I just show you options. Set up visualization tools such as Tableau, Looker, Data Studio, which is a data portal, Redash. When trying to automate continuous integrations, GitHub, Sago.ci, and PyTest might be common options, as some of you already know. After setting up CI environments, you can deploy on GCP. AWS is, of course, is okay. So these might be typical options for ML APIs, as some of you might already know too. So also you can monitor the response speed of ML APIs and check the response by implementing system logs and analysis logs in advance. It is useful for engineers to find the drift of model and debug the code. So I suggest that you look up Flask or Python-based frameworks such as Flask App Builder, Dash, and Locust. So Flask App Builder allows you to manage and visualize data. Dash can make it possible to interactively communicate with the data. Locust is a test to Locust is load test tool, which can also allows you to do scenario test. So these cloud services and tools should be used depending on service size and phases. If you need to consider scaling, you might need to think about the pipeline architectures. But I think that what I talked in this talk is the general and common tips in any phases. There are already a lot of resources about the tools on the web, and tutorials are already presented in the past Python around the world. So you can look over them by yourself later. I'm going to share this slide on my Twitter. So if you have interest in, so you can follow me. So and you can look over it later. So last step. Last slide. So let me quickly summarize the 4 steps to transform research-oriented code into MLPIs. So first step is to understand what research-oriented code in your project looks like, and what components and MLPIs are required in your projects, and how to handle research-oriented code. So next is to modularize research-oriented code through 3 small steps. These are to categorize it into preparation code, pre-processing code, and ML code or calculation code, and break them out into functions and make them testable, and then glorify input and output of each code and define URI. So thirdly, it is refactoring. After preparing for refactoring, simplify IO code in preparation code and change coding style with pandas into Python only in pre-processing code. So lastly, write code to check how it can work correctly by implementing decorators and setting up production-like environment. So that's all. Yeah, that's all. Thank you so much. So if you have an interest in the education technology domain or refactoring ML APIs, yeah, feel free to contact with me. So yeah, thank you so much.